Java offers what's known as nested if statements, which allow you to execute very specific conditions. But these can become quite granular and cumbersome, although there are reasons why you might want to use them. So let's take a look at nested if statements. So see this example here. Let's imagine we're writing an app that allows students to sign up for a course, like an honors level course or an advanced level course, like Java 900, which I'll be teaching next semester. So just to keep things simple, right? You must be a current student in order to enroll in any class at a school. So let's get a variable here. Let's imagine that we ask, we read this information from a database, or we get it from a file, or we have a form online and it says, are you a current student? Check yes or no. However we get the information, this is just standing in for something like that. So we have this value called is current student, and we'll just say that's true. We'll just assume that we know that that's true. So if somebody is a current student, without any other checks, we could say the student can enroll in a class. But if they are not a current student, then they're not eligible. That is like a very clear prerequisite, or I should say a criterion. However, if we are talking about a more advanced level class, there are in fact prerequisite classes that you need to take in order to get into Java 900 or Biology 400, something like that. Like, you don't want to throw somebody into calculus if they haven't taken remedial mathematics. Ask me how I know that. So anyway, let's add in another condition here. We'll call it meets prereqs. And let's just assume that's true. Again, this could come from a variety of sources, like your student records or something like that, Workday and all that. But we could throw that in there. And so now we can start throwing in nested if statements. So if a person is a current student, that is a defining criterion that needs to be true in order for you to sign up for any class. But now this is a little bit more specific. We can now ask, okay, if you are a student, do you meet the prerequisites to sign up for this class? And so we do so, or we write this inside of the first if statement. So you must be a student already in order for even us to ask, have you done the prerequisites? So we do that simply by putting an if statement within another if statement. And we can take out this positive condition from the outer if statement. We take that out and we put it inside of this nested if statement. So you need to both be a current student and meet all prerequisites in order to enroll for that class. However, since this is a totally independent if statement within an if statement, we can also address the false condition. And it's a very specific false condition. So we can say just else, and we can print a message that says, you are missing prereqs. So there are two kind of independent if statements here. And in this case, you can fail on both counts. You can fail on one count or both. And so if you fail on and they're actually sequential too. So if you fail on the criterion is current student, if you're not in the system as a current student, we don't even care if you meet the prereqs. This will never run. This inner if statement will never even run if you are not a current student, if this is false. And it will print the message, you're not eligible to enroll. It could say something very specific like, not a current student. However, if you are a current student, then it will check, do you meet those prerequisites? If you do, then we say you can enroll. However, if you don't meet the prereqs, you are a student, but you still can't enroll because you are missing the prereqs. So we get specificity here. So if we ran this, we would see that student can enroll. Let's see what happens if we say you are not a current student, not eligible to enroll, not a current student. And on the finally, or on the third case, we'll say you are a current student, but you do not meet the prereqs. So we'll get that very specific message, you are missing prereqs. We could also say something like you are a current student, but you are missing prereqs. But that's just a choice that we can make. Additionally, in addition to prerequisites, let's say that there's also a GPA requirement. So in addition to meeting the prereqs, you also need to have a GPA of a certain amount. So now that's another condition that we need to clear in order to enroll on those advanced level classes. So if we take out that student can enroll statement and instead add in a third or a second nested if statement, so in this case, GPA is a double, so we can use the relational operators to verify if it's at a certain number, greater than a certain number. So in this case, with a Boolean, we can only check true or false, but with a number, we need to compare it to another number. So in this case, we say, okay, well, is the GPA higher than 3.0? So only in this case, after passing two other challenges, essentially, only then can a student enroll. However, if the student is a current student and meets the prereqs but doesn't have a good enough GPA, we can also print that out. Does not have high enough GPA. So if I zoom out a little bit, we see that it's getting a little bit it's getting a little bit complicated, cumbersome, but the specificity of it is good because you want to be able to tell your user sometimes what they're doing wrong, what do they not meet, what do they need to work on in order to pass on to the next, to be granted access to whatever. And then just to wrap up this example, if we had a Boolean called can enroll and we started off as false, then we would want to set it to true only after the user passes all of those criteria. And then, of course, we could later say if can enroll, then the enroll access code is something, some kind of a password we could give the student to enroll. So Java offers a way to avoid complicated nested if statements, although you will lose some granular specificity, which can actually be a good thing. The way to avoid complicated nested if statements is to use Java's logical operators. So Java has 3 logical operators. They are and, or, and not. So while the relational operators are used in Boolean expressions to produce true or false values, Java's logical operators allow you to combine or modify Boolean expressions. So as I mentioned, they are and, or, and not. So they allow you to combine existing Boolean expressions and evaluate them all at once, or modify them in the case of the not operator. So let's take a look at these. To explore the logical operators, let's take a look at some of our existing code, but we'll just simplify it down. So again, in this program, we have is current student, meets prereqs, and the GPA. So the relational operators and the Boolean expressions establish whether something is true or false. So this is the true value here is fed directly into the if statement. So is current student, all we have to do is look up and see that that is true. So this block will execute. But then if we want to combine it using the logical operator, we can combine it using the AND operator, which in Java is 2 ampersands. And then on the right side of this logical operator, we put another Boolean expression. So meets prereqs. And then in this case, we've already tested for 2 conditions. The rule for the logical AND operator is it's prohibitive. It's exclusionary in the sense of we have 2 Boolean expressions: is current student and meets prerequisites. Does this person have both? If either one of those is false, then this statement then the whole statement is false. So in this case, is this person a current student and do they meet the prerequisites? If both of those are true, then the student can enroll. So it is prohibitive. Both must be true in order for the entire statement to be true. So that's the AND. Now, let's think about the OR operator. The OR operator is written with 2 vertical lines. In this case, it means, is the student currently a student, or do they meet prerequisites? Now, that doesn't make too much logical sense to us. It does make sense to say, is the person a current student and they meet prerequisites? We want both of those to be true. But we certainly always want is current student to be true. But maybe there's a condition where the student can either meet the prerequisites or have a really high GPA. In this case, what we could do is we could say GPA greater than 3.4, for example. So what this is saying is it's combining two Boolean expressions. Is the GPA higher than 3.4, or do they meet the prerequisites? And let's even say that, if you don't meet the prerequisites, you need to have a very high GPA, higher than 3.7. So in this case, let's take a look at this student's attributes. Well, they do meet the prereqs, but look at their GPA, it's 3.5. So let's run this and see what happens. So our code returns that the student is allowed to enroll in the higher level class. That's because OR statements are permissive, whereas AND statements are exclusionary or prohibitive. OR statements are permissive. So again, we can switch between ORs and ANDs. So in this case, we want the student to have that really high GPA and meet prereqs. And if we look at the current state of the student, they don't have that GPA requirement. So if we run this, it looks like they are ineligible to enroll. And in fact, of course, we should add in our else statement. So we definitely want to make sure that we have our else statement in there so that we evaluate the conditions, and if we get a false result, that we indicate that to the user or to the system in general. And of course, we can combine conditions. We can combine multiple conditions. So the previous code, which is written right here, we had 3 conditions that a student had to meet in order to sign up for the course. They had to be a current student, they had to have the prereqs, and they had to have the GPA requirement. So if we want to trim this program down, we could start off and say if is current student and meets prereqs and GPA is higher than 3.0, which is what the original requirement was in the last program. So now we've taken this code right here, which is maybe like 20 lines or something, or maybe less than 20 lines, but it's 15 lines or so, and we've reduced it to 4 lines. So basically we cover all the conditions in a very short nested if state. I'm sorry, not nested if statement, the opposite of nested ifs, in a statement which uses if statements which are separated by logical operators. Now, I did mention that we lose specificity. So as this program currently stands, we actually only have 2 choices. Can the student enroll or can't they? And so it's kind of up to you as the programmer. Do you want to provide feedback to the user about what they've done wrong or what they need to improve in order to get access? Like if you had a user login and you had a nested if statement saying for the username and then for the password, you could check both of those and you could tell the user you had the right username but you had the wrong password, or you could tell the user you had a username that doesn't exist in the system. Now, in terms of security, it's actually better to only tell the user a generic message, to not tell them you got the password wrong but the username does exist, because if it was a hacker, they would know that the username exists and now all they have to do is figure out the password. So that's just a little something to consider when you're designing systems like this. So those are the and the or logical operators. Now I said there was one more, and it's the not. And just before we move on, I also want to say that you can mix and match. So we said earlier about meets prereqs or has the GPA requirement. So that could actually be an or statement. And it is evaluated like this. It says, this must be true. You must be a current student. And then one or more of these conditions must also be true. So at least one of these two conditions needs to be true, but this one does absolutely need to be true. So you can combine the and ors. You can add multiple logical operators to combine Boolean expressions, but they will resolve to a true or false based on the rules of how and then how or works. So finally, the last logical operator is not. And this is a unary operator, which means that it only takes one operand and produces its opposite. So if we had a Boolean, called logged in, and we set it to false, and we said if logged in, assume we can say, welcome to my site, else you must log in. So this does not have the unary operator in it yet. I'm just giving an example. So we have this, and we're saying that logged in starts off as false. Maybe we have some login logic, which we don't see here. But basically, if you are logged in, that's fine. You can see what's in the site. But if you're not, then we need the person to log in, or we need to transfer them to a login page or something like that. So if we run this, of course we see you must log in. So now, in the case especially of a login, something extremely important is to make sure that they're logged in. And so you might not even care about this positive condition. This positive condition might come way later. Like, let's say you tried to go on Facebook and you went to the URL facebook.com/profile or whatever, and that's supposed to be the secret area or the user's area after they're already logged in. We wouldn't want to say anything positive. We wouldn't want to say like, yeah, you're logged in, great job, because you're not. Essentially, the only thing we know about this person is that they are not logged in. So we don't want to say anything positive. We only want to say the negative, the false. We only want to check if you are not logged in. And so to do this, essentially, you add in the unary operator here, which is the exclamation mark. And now we're saying if not logged in. And this flips the whole logic on its head. So what we actually want to do is remove this statement entirely right here. Like this. So now the user is not logged in, and we say if they are not logged in, we only want to tell them you must log in. So essentially what the not operator does is it flips the expression around, and it only gives you the negative case, the false case. So let's just say these two lines or these two statements will work exactly the same if you have the negative case, if you're not logged in. So the not operator here, it does the opposite. It evaluates the Boolean expression to the opposite of whatever it is. And it is useful if you are testing for the negative case. So we don't care that a person is logged in at this point, but we do want to make sure that they are not able to get in if they're not logged in. So that's the not operator in essence.